In this video, we're going to review some of the basics for the foundation of the course. Maybe it's been a while since we've done some of these things. So part 1 for this 1.1 prerequisite review is on fractions. This is for Math 99 and Math 140 also. So you have a video companion worksheet in Canvas that you can follow along with if you would like. I encourage you to stop the video, try the problems, and then see how you did. You might go through these really quickly and just need to see the answers, or you might need to go step by step. That's up to you. So the first problem here says reduce 85 divided by 306. That's our fraction. So we want to break down 85. We'll use the prime factorization method. That breaks down to 5 times 17. Once I hit a prime, I usually circle that so I can keep track, especially if I have a long list of them. 306 would break down to 3 times 102. 3 is a prime, so I circle it. 102 breaks down to 2 times 51. 2 is a prime, so circle it. 51 breaks down to 3 times 17. You may see right off the bat that 17 is your greatest common factor. But some of these, when they're larger, and especially because we're going to be doing these with variables, we want to have a technique that we can use. So in the numerator, I'm writing 5 times 17 to represent the 85. In the denominator, I'll write 2 times 3 times 3, or even 3 squared I could put, times the 17. Now we can see that we have a common factor of 17, so we can reduce that. So I just slash that out, replace it with 1, and now my answer would be the reduced fraction 5 in the numerator and 18 in the denominator. So that is, my answer is 5/18. For the next one, we have subtract 19/30 minus 11/42. So we need to get a common denominator, and then we keep the denominator and do the operation in the top. So we're going to use that same technique here. I'll do this one in a different color. 30 breaks down to 3 times 10. 3 is a prime, circle it. 10 is 2 times 5. Those are both primes. 42 breaks down to, we could start with just putting 2 in might be the easiest thing for you, however you want to do it. 2 times 21. And then we have 3 times 7. So for lowest common denominator, we want to write that as the product of distinct primes. So we need to have 30 represented here. So I'm going to write that in the purple. We have 2 times 3 times 5. So I know that 30 will divide in without a remainder. 42 is actually going to be 2 times 3 times 7. So I already have a 2 there, so I'm not going to write it again. I have a 3, but I don't have a 7. So you can see 2 times 3 times 7 represents my 42, so that will divide in evenly. To get my lowest common denominator, I just simply multiply those together, and it would be 210. So now I need to build equivalent fractions here. So I'm going to write a fraction bar with 210 in the denominators. So the 19 has to change in this 19/30. So what did I multiply by to get 210 was 7 in the numerator and denominator. Have to be the same. So multiply by 7/7, and then I will get 133 divided by 210. The same goes for the 11/42. I need to multiply top and bottom by 5/5. So then I get 55 in the numerator and 210 in the denominator. Now I just keep my denominator as 210 and I perform the operation in the numerator, and I would get 78 when I do 133 minus 55. That gives me 78 divided by 210. Now I do have a greatest common factor of 6, so I divide by 6/6. It has to be a form of 1. And then I get 13/35 as my final answer. Continuing on with problem number 3, subtract 2 in the numerator over x to the 4th minus 11 divided by x to the 3rd. So again, we need to get a common denominator. So that would be the smallest value. In this case, these are rational expressions. So they have, meaning they have variables in the denominator. So I need to get an x to the 4th, because that's what both of those would divide into. So I'm going to multiply the 11 over x cubed by x over x, and then that will give me 2 over x to the 4th, that stays the same, subtracted 11x over x to the 4th. So again, I'm going to subtract the numerator, just perform the operation. There's no like terms, so I can't combine anything, and then my denominator stays just the same, and that would be my answer for that. I don't want to try to cancel anything. I can only cancel factors with factors, not terms with terms. That's a pretty common mistake. Some people might be tempted to just cross out those x's there. So just leave it just like that. We'll get more into that later in the course. Now number 5 is just following your order of operations. So we have here a bracket, 6 plus 4, open parentheses, 2 to the 3rd, minus 2, close parentheses, and then close bracket, all in the numerator, divided by 12. So we're going to start with the grouping symbols way on the inside. So we're going to have the bracket, 6 plus 4, open parentheses, then I do that 2 cubed because exponents come first here. So do the 8 minus 2, close parentheses, close bracket, over 12. When you're doing this, you can streamline the process. I'm just writing out all the steps, so just in case it's been a while since we've done this. So again, bracket, 6 plus 4, that has to wait until the end. Then the 8 minus 2 can be done inside those parentheses to give us a 6. Close bracket, all over 12. Then in the numerator, now we can drop those brackets. We can have 6 plus 24. Make sure you do that multiplication first. Divided by 12. And then perform the operation in the numerator to get 30. Did that 6 plus 24 over 12. Now we can see we have a greatest common factor of 6. So divide by 6 over 6. And we get 30 divided by 6 in the numerator gives us 5. And 12 divided by 6 for the denominator gives us 2. Now it's just fine to leave it, and actually pretty good to leave it as a reduced improper fraction. Sometimes people think simplified means to write it as a mixed number. In this case, it would be 2.5 or 2.5. You can write it that way, mainly for application problems, or if you started with mixed numbers, you might choose to go that route, but typically we just want to leave it as a reduced improper. Thank you for watching.